Okay, so this video is going to be about partial fraction decomposition. And what we're going to try and decompose is this 1 over x to the power of 4 plus 1. Now, I was trying to integrate a function yesterday, square root of cotangent x, and this is what came up. And the algebra involved in doing this was a little bit tricky, so I thought I'd designate its own little video on just this part. So 1 over x to the 4 plus 1. So first stage is try and factor this denominator. So let's have a look at x to the 4 plus 1. Now we can break this up into two squares by writing x squared plus 1. And as we've got a plus 1 here, we can write the same one again. So we've got x squared plus 1 again. But now you'll see now we've changed the value here now. We've got now an extra x squared term, which is 1 times x squared and another 1 times x squared. So we've now got plus 2x squared. So if I just subtract 2x squared, that's going to be the same value. Okay, so our x to the 4 plus 1, what our end goal is to try and get x squared and then a term in here, which we don't know yet, and then another one. Bearing in mind we've got a plus 1, and of course this coefficient here is also plus 1. We want another one, and with another plus 1 as well. So what really we're looking for is minus 2x squared. And then we can work out what we can plug in to this value here. Now what we want is minus 2x squared to multiply out from these two terms here. So if we take the square root of minus 2x squared, so let's write that here, square root of 2x squared, we can find out the square root of that by taking the square root of the coefficient. So we'll end up with root 2, and the square root of x squared is just x. Now as the term disappears over here, we're going to need a plus and a minus. So when we multiply them all out, we'll have this term multiplied by maybe a positive on this side, and this term multiplied by maybe a negative on this side, and those two will disappear. And the same with this constant. So they will also disappear. And then what we want to do is to get minus 2x squared when we multiply the two together. So if I write, let's put root 2x on this side. So that takes care of that. And then on this side, I want a minus root 2x. So let's change that sign and put minus root 2x. Okay, that takes care of that. So now what I can say is that this factor in here is the same as my x to the 4 plus 1. So now I can rewrite this function here. So I can say 1 over all of this. So let's try and fit this in our denominator. X squared plus root 2x plus 1 multiplied by this one, which is x squared minus root 2x plus 1. That is the same as this. Okay. Now our goal is partial fraction decomposition. So basically what we want this in the form of is if I just take this off the board, so we know that this is the same as this, and now we need to find some decomposition terms where I use my a over x squared plus root 2x plus 1. Now this is a quadratic. So therefore my term in the top must be a linear term. So therefore I'm going to need ax plus b. And then write this one in the bottom. And then this one here is also a quadratic, so I'm going to need another one of those in my numerator. Okay. So that's my building blocks for my partial fraction decomposition. Now the next thing I see is here, these here have no real solutions. There's only complex solutions for this. So that's not going to work for trying to plug in a value. So I couldn't plug in a 0 or minus root 2 or 1 over root 2. None of these terms are going to cancel out. So no cover-up method is available to us here. So basically what I'm going to have to do is I'm just going to have to multiply both sides by this function here. That way then I can get my ax plus b and my cx plus d to multiply out by either of these terms. Okay, so let's do that. So if I multiply this side by this term, so I'm multiplying that by this one, this term is just going to cancel out and just give me 1. And then this side, my ax plus b, if I put that in brackets, multiplying that out with this term, I'm then going to have this term here will cancel out with this term here, leaving me with 1. Then it's only going to leave me with this term here. So I'm now going to be left with x squared minus root 2x plus 1. And then the same with this one. So I'm going to have my cx plus d in brackets. And then all that's going to happen if I multiply this term with this term here, my x squared minus root 2x plus 1, as I've got here, will cancel out to leave me with 1. And then my numerator will just have this term here. So now I'm going to be left with x squared plus root 2x plus 1. So this will now equal to 1. So now I need to expand all of this out and try and get some corresponding coefficients. So therefore then I can solve for something that equals just a constant, which is 1. So let's go through that process now. Let's do that with all these. So let's distribute my ax with all of these terms. So now I'm going to get ax cubed minus a times root 2 x squared, and then ax times plus 1 will just give me ax. So now distribute the b with all these terms. So now I'm going to add bx squared minus b root 2x plus b. Okay, so that is just that bit there. Now I need to do the same with this one. So I'm just going to bring this down on this bottom line here and just indent it a little bit. So let's distribute cx with all these terms. So now I'm going to get cx cubed plus c root 2 x squared and then plus cx. And now just distribute d with all of these terms. So now I'm going to get plus dx squared plus d root 2x plus d. Okay, now I need to try and match corresponding factors now. So my x squared here I can match with, my x cubes I can match with. Let's go for that on the next line. So let's get my x cubes together. So now I've got x cubed a plus c. Okay, now let's get the x squareds together. So now let's work out an x squared. Now I want to try and avoid a negative as my first term in the bracket. So I'm going to just write a b, if you don't mind, for the first one. So plus a b, and then I can subtract a minus a root 2. And that's not my only x squared term. I've got 2 more here. So plus c root 2. And another one here, which is plus d. So that's my x squared terms. So let's just put these lines here. I'm going to need these to try and keep things nice and clear. So now carrying on down now for my x term. So x, so get all the x's together. I've got positive a minus b root 2 plus c and minus d root 2. Sorry, plus d root 2. That nearly all went wrong there. And then my constant terms is just 2, which is a b and a d. So I just put them in brackets just to keep it simple. Okay, so now what I'm going to do is I'm going to take this up to the top and continue with that from there. So now we're all set up, ready to find corresponding coefficients. Now my x cubed here, I can see there's no coefficient for x cubed, so that's going to mean a plus c is going to be 0. So let's start with that. A plus c equals 0. And the next simple one we can look at is this one here, b plus d, which is my constant. Well, there is a constant on this side, so that's equal to 1. So we've got b plus d equals 1. So that now means we can use this x squared and my x. No coefficients here, so we can set these two terms with the square roots inside, set them equal to 0. So now I'm going to have b minus a root 2 plus c root 2 plus d equals 0. And very similar looking equation. This time I'm going to have a minus b root 2 plus c plus d root 2 is also 0. So here's my system of equations. So I've got an a plus c equals 0, which I've also got an equation for. So maybe I could break that down to just those two terms. I've got b plus d equals 1. So maybe I could do something here by just plugging in a 1 there. And then maybe I could solve for some an a or a c or a d or a b and work from there. So as my a plus c equals 0, I'm going to start with equation 4 and then rewrite equation 4 as minus b root 2 plus d root 2, that's 0. So with that fact there, this equation stands. And then as I've got a b and a d here, I can set up some simultaneous equations if I multiply this by square root of 2. So I've now got b times square root of 2 plus d times square root of 2. And as it's 1, multiply that by square root of 2. And that's all valid. Okay, now I can get some terms to disappear now. So now I could just add these together. So if I just add, these two b's will disappear. Then I'll be left with 2d root 2 equals root 2. I now just divide by 2 root 2 on both sides, and I get my d equals root 2 over 2 root 2. So therefore my d will equal 1/2 when they cancel out. So there's one value I've already got. Okay, now let's see if we could do something with equation 2 and maybe equation 3, because b plus d, that's going to be equal to 1. So let's rewrite this. So if I put my a minus root 2 first, plus c root 2, and that is equal to 0. But my b and my d, I should have a 1 here. So I can substitute that for 1. But then if I want to get my a and my c on its own, I'll substitute 1 from both sides. And then I'll have minus a root 2 plus c root 2 equals minus 1. Okay, so now the next one I need to look at is where I've got an a and a c, which is this one, which is set to 0. So if I multiply all these by square root of 2, I can do the same as I did before with my b and my d. So a plus c times root 2. So I'm now going to end up with a root 2 plus c root 2. And then multiply this by root 2. I'm just left with a 0. Okay, so now what do I want to do now? Well, maybe I want to try and find the c. So let's subtract. Let's just add, So I'm going to add again. So in which case these two terms are going to disappear. And I'm left with 2c root 2. And that's set to minus 1 plus 0. That's just minus 1. So as before, divide by 2 root 2. So then I'm going to left with c equals minus 1 over 2 root 2. Okay, so that's my C taken care of. Okay, right, let's take these off the board and let's see if we can solve for some others. So I've got A plus C equals 0, and I've got C equals minus 1 over 2 root 2. So I can rewrite equation 1 as A plus minus 1 over 2 root 2 equals 0. Well, if I want to set this to 0, all I need A to be is the positive version of this. So basically A is going to be 1 over 2 root 2. So that takes care of that one. So let's put this one over here. 1 over 2 root 2. And now do the same with my B and my D, because I think D is equal to 1/2. So let's just try that. So B plus D equals 1. My D is 1/2. So let's just plug that into there. So B plus 1/2 equals 1. So quite simply B equals 1/2. So let's write that in there. Okay. Okay, so here's my building blocks I set up for the partial fraction decomposition. That was our original question with 1 over x to the 4 plus 1. So we then did our solving with corresponding coefficients, and we got these values of these coefficients here. So now we're ready just to plug these in, and we're ready to have our partial fraction decomposition completed. So let's do that. So let's set up the fraction first. So in brackets I've got x squared plus root 2x plus 1, and I've got ax plus b. So my a is 1 over 2 root 2. Well, if I write a 1 over 2 root 2, I'm just going to write 2 root 2 in my denominator and just put in an x. That will take care of that. Now my b is 1/2. Now I can't just go straight in here and just write in 1/2, because I've changed the value, because that's going to be divided by 2 root 2. So if I multiply this half by 2 root 2, I'm not going to change the value of this fraction. So 1/2 times 2 root 2, these are going to cancel out, and it's just going to leave me with root 2. So if I just write root 2 in there, that will then complete this side of this equation. So now let's have a look at this one. So setting up my denominator, x squared minus root 2x plus 1. Now I've got cx plus d. Now I didn't put a sign here yet, because I see I've got c here is minus 1 over 2 root 2. So instead of this plus, I'm going to use this minus sign here and put it here. So now I've got minus. And then, as before, I can write 2 root 2 in my denominator. So it takes care of that. So therefore then I'm ready just to write my x in the top, because I've got my c in my denominator. Okay, so that takes care of my x. Now I've got my d. So my d is 1/2. Now, as I had before, if I multiply by 2 root 2, I'm just going to be left with root 2 in my numerator for my d. But I just need to be a little bit careful here, because I've got a minus sign here. So I'm multiplying by minus 1 over 2 root 2. So if I put a minus sign there, as was my c here originally, I'm now going to end up with a minus sign here. So now I'm going to end up with minus root 2. Okay, and then that is our partial fraction decomposition. That completes it for 1 over x to the 4 plus 1.